Hello everyone. Today I am going to discuss about the probability distributions and its role in data science. In the previous lecture, I have discussed on the probability, the basic probabilities only. Let's start. So first, what you have to know that is what is probability distribution. Actually, it tells the behavior of the data set, like which values happen more often, which are there, like this. This is a very crucial thing to create any AI model or machine learning model. Say for example, the marks of student. Here you can see 10, 20, 30, 80, 90. These are the marks. Here we can see that 10, 20 and 30 are low numbers. For 80 and 90 are very high. That means the data is not normal distribution. Okay, some values are very low, some are very high. Okay, so actually distribution is a you can say shape of your data. So why do data scientists care about probability distribution? Let's make you understand what is the role of distribution in data science. So first thing is to understand what is normal versus abnormal. Like real data always has variation. Example, salary data. Here you have 40K, 45K, 50K, 55K, 60K. This is a salary. Okay. So that means most of the people are around 50 to 60K. Now imagine, suppose one employee get 5 lakh salary. What? Then question is this normal or suspicious? So actually distribution helps to answer this question. So 5K salary is very rare and possibly anomaly. Okay. So that means for fraud detection, anomaly detection, risk system. Okay. So the role of distribution is crucial. This type of field. Second is to choose the right ML model. Okay. Suppose you are planning to create a machine learning model. So very crucial thing, what the model you should create. It's a crucial thing, and you have to identify this the model based on your data set. What is the shape of your data? Okay, and this distribution actually tell you or guide you what model you have to choose. For example, data is if data is normal or bell shape. I'll show you. Bell shape means the in the graphical uh, picture. If I can show you, this is a bell shape. Okay, you can use linear regression or logistic regression model. Later on, I will discuss what is linear regression, logistic regression. Just for now, just just remember this name only. If data is not normal, in that case, we can use tree model or transformations. Okay. That means wrong. If your assumption is wrong, then your model will be wrong, and definitely result will be bad. So that's why distribution is very crucial thing in data science. Third one, to improve model performance. Definitely, for example, income data, you can see 10k salary is 10k, 20k, 30k. But here you see the salary is very high, right? One salary, one employee salary is very high. That means your data is not balanced. In that case, we have to apply transformation to make data normal. In the previous lecture, I also shown that how to normalize data. But in a later lecture, I will also show you how to normalize the data when we'll create any machine learning model. Okay, and that means it helps to make the model more accurate, right? To detect outlier. Same. Actually, I already shown you what is Z score. Okay. So from the data, you have to find out a Z score and is to compare and in that way, actually, you can find the outlier of the data and then you have to cleaning. Okay, clean your data. Okay, and you can also detect a fraud. Okay, sensor error. This type of things you actually uh, uh, use our data distribution. And also to understand the uncertainty. So ML is not about the exact answer, actually prediction equals probability, right? Like and in the last video I have shown you the uh, how to calculate a probability. The model is using distribution internally and predict a outcome. Later on we'll discuss deeply. So you will evaluate the model result as well. For example, here follows distribution. Example prediction errors like -2, -1, 0, 2. Okay, it looks like a normal distribution, right? If some value is bigger or very less, then in that case we can say model is biased. So in that case we have to evaluate our model to make it better. So we can, based on the distribution of the prediction error, we can evaluate our model. So we already discussed the feature scaling comparison also help. So in that case also we need the distribution. So distribution actually very vital thing. So we can say data science equals to understanding data behavior and distribution equals to behavior. Okay. Now I'm going to discuss the four types of data distribution. First one is a normal distribution. Actually, in this, actually here data is normally distributed. So all the data very close to their mean or median, right? That means most value is close to middle. This is a middle and the graph is, if you plot the value and the data science graph will be bell shape, right? It's like a bell. In this case, most values are in the middle and few values are in the extreme. You can see these extreme values actually stay here. And most value you can see close to middle. The color is light yellow. Okay. For example, most students score is 50 to 70, but few score 0 or 100. So this type of data we can say is a normal distributed, not normal distribution. Okay. So why important ML is helps answer what is normal versus abnormal, right? Example, salary is 50K is normal, but salary 5K is outlier, right? Now binomial distribution. Actually, it helps to answer you like yes, no, success, failure, this kind of answer it will give. We will get only two outcome. For example, if you toss coin 5 times, possible 3 head, 2 heads. Okay, sorry, 3 head, 2 tail, maybe the possibility. I actually missed it. This is my mistake. It will be, it should be the tail, right? Okay, actually, you have two options, either head or the tail. Why important ML? Suppose you are told to detect the email spam or not. Okay, whether in any retail portal, okay, whether customer will buy or not. Okay, so this kind of data analysis we use the binomial distribution. Okay, you can see the graph for binomial distribution. Graphs looks like this, and also I can show you the more details. You can see the probability of distribution of a coin toss, right? This is the probability and the head and tails. Fold heads is this, probability of tails is this. Okay, another picture, binomial distribution of coin toss, where n number equals to 10 and p equals to 0.5. You can see, okay, number of tail per 10 coin, 10 coin toss. Okay, this is the graph 1 to 10. You can see result of 10,000 coin flips. Okay, it's for head and I was for the tails. Okay, it's a tails graph and it's a graph for heads. Now the uniform distribution, it's a very simple one. Here all values are equal likely. Okay, that means probability of is equal. Like suppose a dice. Okay, dice have 1 to 6 number. Okay, All are the same. If you draw a die, so the probability of getting any number is same. This is called the uniform distribution. When we use, when we want randomness, bias, when we want the output of the model should be random. This is very useful in that case. Now, Poisson distribution. Actually, it counts the events over time. It counts the events over time. Like call per hour, website visit per minute. Very important. How many events will happen? If you need output, this kind of how many events will happen in a specific time range. So this distribution is helpful. It's a graph of the Poisson distribution. Call volume prediction. This is the probability and number of our calls. You see, it is this graph is similar to uh, binomial. Okay, not needed more details for Poisson distribution right now. I'll in a later tutorial I will explain. Okay, but for now we don't need more details. So that's why I'm not discussing this thing right now. Okay, to make this tutorial lecture very simple. Okay, first know the basic thing, then I will deep dive into detail thing. So in this is the overall view of all the four distribution. So normal mean most value in middle, binomial means yes or no outcome, uniform mean equal chance, and Poisson means count event. And also you can see the example for each distribution. Normal is usually used for fraud detection, binomial spam detection, uniform randomness, and Poisson website traffic. So one example. Many examples are what they are, but one example here we have given, right? So that's all for today. And if you have any question, you can post in my channel, and so that I can later you can discuss, or in the same comment I'll reply. Thank you.